All right, the geologic history of New York State. So these two pages actually correspond with one another. So when you have them open in person, you need to make sure that they are opened up together. Okay, so let's start way over here in the eons. So you can see right here, if you follow this down, this is the eons. I'm going to actually zoom in a little bit to show you that we have the Phanerozoic here. This is the most recent. And then underneath that, we have what they call the Pre-Cambrian. You can see the millions of years ago listed. Okay, so here's 1,000 million years ago, which is a billion years ago. Here's 2 billion years ago, 3 billion years ago, 4 billion years ago, and Earth actually was created about 4.6 billion years ago. That's how old the Earth is. All right, this is all the Precambrian. So if we break down this a little bit farther, you have two sections. You have the Proterozoic, and then you have the Archean. The Archean is oldest. It's older. And then they break that down into early, middle, late, so on and so forth. Okay, so this is the Precambrian. If you look at these right here, the estimated time of origin of Earth and solar system, that's at that 4,600 million years ago, or 4.6 billion years ago. Same thing. The oldest known rocks followed across here, evidence of biological carbon, earliest stromatolites and oldest microfossils. So that goes about 3,000, I'd say about 3,300 million years ago that happened. Then you have this chunk of time right here where the oceanic oxygen started to increase. So this started to create some different things. Oceanic oxygen began to enter the atmosphere. So the oxygen actually left the oceans and started to get into the air. And then when you get to the middle Proterozoic here, something happens. So this dotted line separates from when there was no biological life at all during the early, middle, late Archean and the early and the beginning of the middle Proterozoic. Once this dotted line hits right here, you get your first sexually reproducing organisms. So this is actually when your single-celled organisms started to evolve, exist, and be around. So this chunk of time here during the middle of the middle Proterozoic to the end of the late, this is where those single-celled organisms kind of started, and you can follow that down. So this solid black line actually will follow down here, and you can see this Epochs fauna, these first multicellular soft-bodied marine organisms. So this was actually all during this middle to late Proterozoic. Okay, then you have the Phanerozoic. So this short amount of time, about 550 million years ago, this solid black line basically explodes across the whole entire chart. So this line you follow straight down, and it brings you to these eras. You have the Paleozoic, which is from all the way down here up until about right here where the Permian is. So that's this chunk of time right here. Then you get the Mesozoic, which fits in from the Triassic all the way to the end of the Cretaceous. And then you have the Cenozoic, which is from the Paleogene on. Okay, so those are your eras. Then you have your periods. Okay, the periods are broken down by different times as well. So you got the Cambrian, which is the oldest, then Ordovician, Silurian, Devonian. The Carboniferous is broken down into two. You got the Mississippian and the Pennsylvanian. The Permian, Triassic, Jurassic, Cretaceous, Paleogene, Neogene, and the Quaternary. Okay, so those are all the periods. Oldest is at the bottom down here. Youngest is at the top. Then if I move over into the epochs, or the epochs, depends on who you talk to. Usually they're called epochs. I like to call them epochs. Okay, they're broken down into early, middle, and late, way down here. And then you can see actually the year. So really the Cambrian started about 542 million years ago. And then if you follow them all the way up, you still have early, middle, late, until you hit the Cenozoic. Why? Because there's a lot of things that we have found during here that we have a lot of evidence for, so they needed to break it down a little bit better. And there was lots of different people who named stuff. So you have the Paleocene, the Eocene, the Oligocene, Miocene, Pliocene, Pleistocene, and the Holocene. Okay, those epochs are all part of the Cenozoic. We don't usually use them too much. You just need to follow it with the life on Earth stuff, because sometimes they'll ask you about the epochs or epochs. All right, so we've already talked about the eons, the era, the period, the epochs, and then we have life on Earth. What they've done here is they've taken all of the largest amounts of animals that were on the planet, and they showed them when they were earliest or when there was the most abundant or so on and so forth. So if you look, oldest ones, the great diversity of life forms with shelly parts. And then you have your earliest trilobites, extinction of many primitive marine organisms, earliest fishes, Burgess shale fauna. This Burgess shale fauna shows up a lot on Regents exams. So make sure you know where that is. For our stuff, it's definitely going to show up. And then so on and so forth. You see these like breaks right here. There's a break right here. There's a break right here. There's a break right here. A lot of times that's when you have mass extinctions or something drastic happens. So in this case, it's the greatest diversity. So there's new stuff. But right here at the end of the Paleozoic, there was a mass extinction of many land and marine organisms, including all the trilobites, which is sad because trilobites are pretty cool looking. Okay. So actually, that's what separates the Paleozoic from the Mesozoic, was this mass extinction. The other mass extinction that separates the Mesozoic from the Cenozoic is when the dinosaurs, ammonoids, and many land plants died. We'll talk about this. You actually learned about this with one of the videos we already watched. Okay, so this is all the life on Earth. The New York rock record shows of the sediment or the types of bedrocks in New York State that are found, and they can find in New York State bedrock from Cambrian, Ordovician, Silurian, Devonian, parts of the Mississippian, parts of the Pennsylvanian, none from the Permian, which is kind of interesting. Some from the Triassic and the Jurassic. There's sediments found from the Cretaceous, but nothing from the Paleogene and the Neogene. And then there's some sediments found from the Quaternary, obviously, because that's the most recent. These rocks and sediments are found on top. Okay, so that's the New York rock record. Now, this next one, this distribution of fossils, these letters actually correspond with the letters down here on the bottom. So if you look at A is an elliptocephala. So that's this little trilobite guy down here. If you turn your head and you look at this bar that this is on, A, B, and C are all types of trilobites. Okay? If you look at D, E, and F, those are all types of nautiloids. So I look at D, E, and F, D and E and F are all different types of nautiloids. Nautiloids are actually still exist today, different types, not the same species, but they're really kind of cool looking animals. We'll talk about them another time. And then G is an ammonoid, which they're cool looking too. There are ammonoid fossils in different parts of New York State that you can find pretty easily, and they're really neat to see. And then you've got crinoids, you've got graptolites, you've got dinosaurs, eurypterids, mammals, so on and so forth. All right? Now, these are all different types of index fossils. If you follow them straight across, so let's say we take B, this Cryptolithus. If we follow B straight across, the Cryptolithus lived mostly during the Middle Ordovician. Okay? So between 488 million years ago and 444 million years ago. If I look at L is the Soelophysis. This is the only dinosaur-looking thing that we can find in New York State. If you follow L across, that will have lived during the late Triassic. Okay? Wherever these lines end, so like the trilobites just ends at the end of the Permian, that's when they all died off and went extinct. Like nautiloids is still going because we still have nautiloids existing. If you look at dinosaurs, they only started to live partway through the Triassic, but then they all died off at the end of the Cretaceous. Okay, so that is the time distribution of fossils in New York State. Then we have the important geologic events in New York State. So if you look, starting down here at the bottom, you can see the Grenville orogeny. That actually happened. If we follow this across, oh wait, we ran into the line. We got to follow it up. It happened towards the middle Proterozoic. That's when this Grenville orogeny. Orogeny is a fancy word for mountain building. Okay, so on and so forth, like the Taconian orogeny, mountain building of the Taconian Mountains, that happened during the early and middle Ordovician. Because remember, mountain building does not happen overnight. It happens over some time. Okay? Salt and gypsum deposits happened during the Silurian, so on and so forth, all the way up. Make sure you're paying attention to what's going on in here. And it follows across for the correct time. Last thing is the inferred positions of Earth's land masses. Basically, it shows you where the United States was at the time on this chart. So 359 million years ago, it was more closer to the equator, and then it started to move farther away until it starts to get around where we are today, which is farther away from the equator, more towards the northwest. Okay? So this chart kind of works up and down and side to side with each other. The hardest part to get, and you might want to rewatch the beginning of the video if you still don't understand how this eon works. Okay, remember this solid black line allows for this Phanerozoic to kind of blow up on your page because all of this stuff has only happened over the past 550 million years. Okay, not a lot of things happened during this Pre-Cambrian. It was very quiet and rocky and lava-y and yuck. Okay, not a lot of life. If you have any questions, make sure that you ask them, and I hope this helped a little bit.